In part A of question 9, we need to find to three significant figures the value of x for which 6 to the power x equals 8. You can see that I've solved this using logarithms. Let's see if we can use the Casio graphical calculator to confirm this result. I'll use the graph function menu, option 5, and the first function I'll key in is 6 to the power x. And if I select execute, my second function is 8. Of course, that means the function y equals 8. And if I select execute, I want to draw these and look at their point of intersection, because that will give me the correct value for x. So if I select F6 to draw, and at the moment the actual scale I've used is not adequate. So if I go to the V window, I'm now going to change the parameters. I'll change the x minimum to a negative value, so let's try minus 10. And I'll change the maximum from 20. I noticed that a lot of the positive values for x were not being used, and so I'll change this to 5 for now. If I go down to y minimum, currently it says 0. Well, there's no need to change that because the function is never negative. However, if I go down to the maximum, I'll change that to a larger number. Let's try 20. Okay, and when I draw it this time, I now get a more clearer picture about what's going on. If I use Gsolve, F5, I can select F5 again for the intersection, and you can see I get the point whose x coordinate is 1.16055, etc. And to 3 decimal places, this indeed is 1.161. And so that confirms part A of my question. In part B, we need to solve the equation 6 to the power 2x, take away 14 times 6 to the power x, plus 48 equals 0. You can see that I made a substitution. I let y equal 6 to the power x, and in doing so, I obtained a quadratic equation in y. Eventually, the values of x I found are x equals 1 and x equals 1.161 to 3 decimal places. If I use the Casio graphical calculator, in the option 5, the graph function menu, I've already keyed in the function y equals 6 to the power 2x, take away 14 times 6 to the power x plus 48. And I can use F6 now to draw this function. And of course, I'm interested in the roots because the roots are the values such that the function equals 0. So if I select F5 for Gsolve and F1 for root, the first root is at 1, 0. So that corresponds to my first solution down here, x equals 1. And if I scroll to the right, I obtain the other solution, 1.160 and so on, which again to 3 decimal places is 1.161. And so the graphical calculator has confirmed my calculations to be correct.